was that there was, and you've heard it all here as we've been talking, there's this big deal about Antarctica as a place to test what would be a candidate that can go into space. So that's good to know. It's also good to know to put a little bit more of the story part into this, I felt. And so as we were planning for this and speaking with Emmeline and Eric in preparation for this, it was important that we got other perspectives from people that have been in extreme environments. And that extreme environment is the term that we have been using when we're sharing the New Zealand Space Challenge. We thought that was a nice term to use. You may have your own, but you're more than welcome to buy that one too. So the idea is that as you're sharing the story, you can share some of the things we've heard today, which is, I guess, the details of the challenge, but also that rich culture and heritage that New Zealand has to a place like Antarctica. So that's the purpose of our next two speakers. And so, Drew, this is where I'd like to invite you in, and I will try and tell you a little bit more to give you a sense of what this room looks like here as well. And I'm also going to share your very brief introduction to what you do on the email that you provided, and then I'm just going to run over and press a button, and I'll put my slide up to get us started, which will be a picture of you, Drew. So,
sounds good.
Excellent. So Drew is dialing in from Hamilton. He's kindly spent some time, obviously, listening to all that we've discussed, and I hope you can hear that. Drew, did you get a good sense of that?
Yep, no, very good. Thank you.
Excellent. So, Drew, Dr. DrewLohrer sits in Hamilton at the moment. He's recently got back from an expedition to Antarctica. He runs scientific experiments using scuba gear in undersea environments. When he was down there last, it was a 9-person team that they led. And Drew, I haven't got it up on the slides, but one of the things I'll do at the end of this presentation is I'll see if we can figure out how this laptop can get connected to the internet and put up the Facebook page for Sea Under the Ice. And the images you're about to see are only shared within this room. I'll let Drew figure out how he can share them beyond that. But obviously the Facebook page has also got some images on it. The images are stunning, Drew. I was really blown away with what you've been able to share, so thank you. The purpose of Drew's presentation is to make that story richer about Antarctica. So that would be the contribution from Drew. And then I wish to introduce Philippa Ross, who has also been to Antarctica, and then also has a rich family history, which I'll allow her to share when she takes our stage too for 5 or 10 minutes. So first I'd like to invite Drew. Drew, if you could introduce yourself. I'm going to stand here with a volume button just to make sure that everyone can hear you. And everyone here will look at me and nod and smile, if that's okay.
Okay, yeah, so greetings everyone. I'm DrewLohrer, and I'm a marine ecologist at NEWA here in Hamilton. And are you able to see my face on the screen yet?
We've got your face, thanks, Drew.
Right. Okay, so obviously I'm not wearing my polar clothing today, so it doesn't look exactly like that, but I'm just calling in to share my experiences of working in what I think is actually one of the most extreme and foreign environments on the planet for humans to work in. You know, as was just said, my experiences have involved scuba diving to conduct scientific experiments underneath sea ice in very cold seawater in Antarctica. So I'm just going to discuss some of the challenges that we face to do that work and how we overcome them. And also I think that there may be parallels for space exploration in terms of problem solving. So if you can maybe just go to the second slide there, the map that shows the continent. Antarctica is the coldest, windiest, driest, and highest elevation of all over the continent. So it is a very extreme place. And this map shows you the land area of Antarctica, which is huge, but there's also millions of square kilometers of sea ice that that go around the coastline that forms every year, which adds to the size of the continent. And I study near-shore marine ecosystems where the coverage by the sea ice is really important. It's an important driver of the biodiversity. The little red rectangle there shows Western Ross Sea, with a Ross Sea dependency there. And the little arrow, if you can see that, points to Ross Island. So the next slide, please, shows should show someone pointing at a map, so that's Ross Island, and that's where SpaceBase is located. And our group stages our events through SpaceBase with the help of their logistical support team. But we usually work in remote field camps atop the sea ice that are 80 to 100 kilometers away. So if you look along the western McMurdo Sound coastline, that's kind of over where we work. So these are some of the southernmost accessible dive sites on the planet. You really can't go any further south than those places. So next slide. So I guess the next slide really is the challenge we face in getting to these remote places, especially because we have so much science gear, diving gear, and camping gear. So you can probably see some little tents and things on the ice there, and then the dry valleys in the background in this slide. And how we get there is that we usually traverse across the sea ice, so using large tracked vehicles that pull big sleds of gear, and you saw some of that in the previous speaker's talk. So it's usually pretty slow going, and one of the things we have to do a lot is stop to check the cracks in the ice so that we don't get vehicles falling through. It's not like a crevasse, but it's just this parallel. Okay, the next slide. So this is a drone shot, a little bit closer up footage of our camp. And basically, the big challenge here is just ensuring, first and foremost, that we're protected from the elements. So temperatures can reach negative 30 degrees Celsius at the time of year we visit. So that's usually October and November. And we sleep in unheated tents. So the little pyramid tents you see there are unheated, so that's where we sleep. And then we've got 3 large tents that serve as, one of them is our diving hut, one of them is our laboratory and sample processing hut, the yellow one there, and the third one is a cooking and eating sort of mess tent. So we also have a toilet tent. We leave nothing behind on site, so again, nothing. We bring everything back with us when we demobilize. Next slide. So that just shows our food tent. So clearly a big challenge when you're planning expeditions like this, planning the resources that you need to bring out to the site. You can't, when you're in a remote field camp like that, you can't just nip down to the dairy to get something. And we had a 9-person team during this year, and we were on site for about 20 days. So obviously bringing little food is obviously bad, and in fact there's a major health and safety risk because food is an important part of staying warm. You need the energy to produce the body. But also bringing too much food adds to your fuel consumption and takes up cargo space and things like that. In terms of drinking water, we had to chip all of our drinking water off of nearby icebergs. So that was kind of cool. Okay, another next slide. So the next big challenge when you're doing science underneath the ice is that we have to get through the ice. And so at the site that we went last year, the ice was 3.5 meters thick. So we chainsawed out blocks of ice and pulled them out layer by layer. And then we finally melted out the final little bit. We punched through and then melted out the final bit using a hot water melter. Okay, next slide. And obviously, again, diving under sea ice presents some obvious challenges. So firstly, it's very cold. So the seawater, because it's salty, does not freeze until about negative 1.9 degrees Celsius. So the water we're diving is just at this freezing point. It really can't get any colder without becoming ice. So we wear dry suits and very thick thermal undergarments to keep us warm. We also wear dry gloves and very thick neoprene wetsuit hoods. The skin around the mouth and lips is exposed though, so sometimes after a dive we talk a bit funny. It's like we've been to the dentist or whatever. Can't speak so well after a dive. And actually, incidentally, I think dry suit zippers, which are a zipper that is watertight, is a technology that I believe was handed down from the space program. And then obviously dry gloves are necessary to stay warm, but they do affect the dexterity of the fingers, and so does the cold. No matter what we wear. We still get very cold after our dive. And so we have to make our sampling gear very simple and easy to use for divers who are very limited in their dexterity and their movement. So a lot of this planning, you have to develop your systems very well. Okay, next slide. And another key challenge with this type of diving, obviously, is that there's a solid roof of ice above you that prevents you accessing the surface if something goes wrong. So we have lots of systems in place to cope with this kind of thing. So including backup breathing systems in case the first one fails. But we also have the tether, so you can see some lines running down from the dive hole there. The tether helps us find our way back to the hole. And in fact, we even have a backup safety hole that we make in case a large willow seal or some other thing is blocking our Yeah, and you laugh, but it has happened. So the next slide is, and the final challenge really, and to us the most important challenge, is doing science underneath the ice. So in this photo you can see some chambers that are deployed to the underside of the sea ice. So these are actually quite large, they're about 60 centimeters diameter each. They hold 140 liters of seawater. And they, in this case, we were studying the algae that grows on the undersurface of the sea ice. And so we had some chambers that we could use to measure their primary productivity, basically the oxygen that they produce inside these chambers via photosynthesis. So, and we're really interested in understanding the effects of climate change and ocean acidification on the productivity of this algal community. And it requires lots of innovative thinking and problem solving. So, for example, how do you get these chambers to stick to the underside of the ice? Well, we developed the chambers have a little air compartment so that we can breathe and exhale our bubbles, and then the buoyancy would sort of stick them and hold them firm up against the underside of the ice. Okay, next slide is just a close-up of the same chambers. We can also see lots of the sampling gear inside them, so we have different types of sensors and augers in them, and then we have umbilical cables that ran back to the science tent that we can use to manipulate parameters of the seawater and control different getting power our instruments. Okay, next slide. And we've done similar experiments on biodiversity and the functioning of the sea floor. So here you can see it's a different type of chamber that we use to do this. And the diver in the background there for scale. So these are about 50 centimeters by 50 centimeters square boxes that we put out in replicate patches to cover replicate areas of the seafloor. Okay, next slide. And apart from this being a challenging environment, just like space exploration, some of the themes we get actually look a little bit like space. They look a little otherworldly. So this is a pretty cool picture of our sampling array. That's actually me in the kind of bottom right area. And if you look at the next slide as well, this is another cool shot. This one is a screen grab from a 360 virtual reality camera that we had deployed to the seafloor. So we're trying to not only study the biodiversity and the functioning of these systems and how they're responding to climate change, but we're also trying to make it accessible to the public so people can understand why and how we do science underneath the ice. So just a final bit, just want to acknowledge, this was a 9-person team, lots of divers. It is a challenging environment, but it's obviously a very fun environment as well. We really enjoy doing what we do. So thank you very much.
Yeah, thank you, Drew. And you're quite right around applause. I think having the challenge and all the sort of the concept of space in your head, then you've alluded to Antarctica, then you've shown us specific images with specific problems that needed to be solved, which I think really helps brings this to life. I asked Drew if he was up for being contacted after this, because if we're sharing stories and you want to pick someone's brain, maybe Drew's your man, or somebody else. But I just thought it would be great if we could continue this kind of discussion as best we can. Drew, the images there have obviously not gone through whatever sign-off procedure is appropriate, so they're staying in this room. But
yeah.
Are they ever likely to be made available?
Yeah, and some of them are already available online. So we have a web Facebook page that's publicly available called Science Under the Ice. If you Google that, Science Under the Ice. You will find out most of these images have already been posted online. They're not the highest resolution online, but yeah, you're welcome to check it out. And there's lots of good captioning information and also videos of our expedition on the Science Under the Ice page. So it's definitely worthwhile to visit that. And certainly we're not hiding anything, we're sharing our information, and that is one of our goals, is to make Science Under the Ice accessible to the public. Because New Zealanders do really seem to care about this. We get a lot of positive responses.
Excellent. Excellent.
Those photos are online.
Okay, great. I'd like to introduce our fourth speaker for today.